Good morning, dear students, and welcome back to our online classes. We are studying about carbon and its different allotropic forms. We have learned about two crystalline allotropic forms of carbon, and they are diamonds and graphites. Now, in our today's class, we are going to discuss about the third allotropic form of carbon, which is a crystalline form, and it is fullerene. The fullerene is an allotropic form of carbon whose molecule consists of carbon atoms connected by single and double bonds so as to form a closed or partially closed mesh with fused rings of 5 to 7 carbon atoms. This allotropic form of carbon was discovered in the year 1985 by three scientists, H. W. Kroto, R. F. Curl, and R. E. Smalley. They were awarded Nobel Prize for their discovery in the year 1996. Now, these fullerenes are very important allotropic form of carbon, and their molecule can have about 30 to 900 atoms of carbon connected to each other by single and double bonds. For example, we have one type of fullerene which has 32 carbons and they are denoted as C32. Some even have 50 carbon and they are called C50, and so on, C70, and so on. But among the fullerenes, the most famous fullerene is carbon fullerene having 60 number of carbon atoms in one molecule of fullerene, and that is C60, and it is known as Buckminster Fullerene after famous designer American architect who designed a dome, and his design resembled the structure of C60, and the name of the American architect was R. Buckminster Fuller. So after his name, since C60 had similar structure like the dome which Buckminster Fuller made, the fullerene was named Buckminster Fullerene. To the surname of Buckminster Fuller, ENE was added, and this ENE in chemistry, ENE stands for unsaturated organic compounds. ENE stands for unsaturated organic compounds. Therefore, the fullerenes are unsaturated organic compounds containing carbon. Now, these fullerenes, they have different shapes and structures. Some are like spheres, some are like ellipsoid, some are also like tubes, and they might have even different types of structure. Some of the structures I will show you so that you can refer to what you can relate to what I am talking about fullerene. This is one structure of fullerene. It's a spherical structure, hollow from inside. And this is the most common fullerene, that is C60, which is also called buckyball, since it appears like a soccer ball. Soccer. This is another example of another fullerene and its structure of one molecule. This is another type of fullerene, which looks like a tube made of mesh, and it is hollow from inside, and they are also called nanotubes. This is the crystalline form of fullerene. This is another example or structure of fullerene. This is again another structure of fullerene, another type of fullerene. This is buckyball. This is nanotube structure. And this is again another type of fullerene having different structure. So in this way, fullerene can have different shape and different number of carbon atoms in one molecule connected to each other. So I hope you are clear now by the word or the name fullerene. Okay, it is the crystalline allotropic form of carbon, which is made up of carbon atoms connected to each other by single and double bonds. Whenever there are double bonds, that type of carbon compounds are called unsaturated compounds. That is why ENE is added at the end. Okay, so these rings are fused together to form larger compound, larger substances, okay, where molecules are connected to each other. Now these fullerenes, they are found in soot. They are also found in soot, and they are found in interstellar gas clouds in the space. Some of the important properties of fullerenes are, for example, we talk about buckyball, which is famous fullerene made up of 60 carbon atoms. Now buckyball is a yellow crystalline solid. Fullerenes can be dissolved in various solvents. Some of the compounds of fullerenes act as superconductors at high temperature. Fullerenes are less denser than diamond and graphite. They are insoluble in water, and like graphite, fullerenes are also soft and slippery, but at the same time they are brittle. And fullerenes mostly have low melting point. Now let us see some of the important uses of fullerenes. Some compounds of fullerenes are good conductors of heat and electricity, although most of the fullerenes are bad conductors. They act as insulators, but some compounds of fullerenes are good conductors of heat and electricity, and hence they have application in electronic devices. They are used in making electronic devices. Fullerenes can be used in cancer as well as in AIDS therapy. Okay, that means in the medical sector, medical sector also, fullerenes have very wide applications. Apart from this, being used in cancer and AIDS therapy, they are also used as antioxidants. They are also used as antimicrobial agents. In different chemical reactions, these fullerenes can be also used as catalyst. Fullerenes can also use to purify water, and therefore fullerene finds its application in water purification industry also. Some inorganic fullerenes, such as inorganic buckyballs, are used in making bulletproof. This fullerene, being slippery in nature like graphite, they can be also used in lubricants. Now, these fullerenes have very wide applications, huge applications, and this enormous applications of fullerene has made this fullerene very, very important molecule in today's science and technology, especially in nanotechnology and industrial research field. That is why in our present time fullerene plays very, very important role, and its important uses are still yet not fully known to us. Therefore, it has become of very high interest to scientists, and they are doing lots of research and study on fullerenes. I hope you found this class interesting, and I hope you will go through your textbook. You can also refer to Google, search in your internet, try to know more about fullerene so that later on you can also take this fullerene as your study. This much for today, boys. Stay safe and do all things well.